Okay, so to solve this problem, let's explore a bit. So up here I've got 3 examples of sets, and I'll write a couple more here. One that's going to be kind of important in this problem is the empty set, which seems a bit weird, but it's just the set containing nothing, right? So let's look at a couple examples of subsets first, just to get the idea down. So if we have the set 1, 2, 3, as in the top left there, we have a bunch of subsets here. So first of all, I'm going to write the subset symbol. So it's this. This means is a subset of. And so 1 is a subset of 1, 2, 3. Because all the elements of 1 come from 1, 2, 3. Now, it might seem a bit weird, but the empty set is also a subset of 1, 2, 3. Because every element in the empty set comes from here. There aren't any elements, but if there that means that it's true, right? If we pick an element in here, we can see that it's in here. Same thing here. If we pick an element in here, we can see it's in here. We just can't pick any elements. So while this might seem a bit weird, it's actually true. Similarly, 1, 2, 3 is also a subset of 1, 2, 3. Because every element in 1, 2, 3 comes from 1, 2, 3, right? And that's why there's this extra line here. It's just like less than or equal to, right? This bottom line means equal to. So it includes the set that's equal to it. Okay, so now let's go through the actual problem. Let's start with all the subsets of a set of size 0. Well, the only set of size 0 is the empty set, right? The only set that contains nothing is this set. If it contains something, it would have a size of bigger than 0. So how many sets are subsets of this? Well, it's actually only 1. It's just the set itself. It's just the empty set. So we know that 0 corresponds to 1. A set of size 0 has 1 subset. Okay, let's look at an easier to understand example. What if we just have a set that contains one thing called x? Well, let's think about this. How many are there? Well, we know that this empty set is a subset, and we also know that every set is a subset of itself. So there's 2 right there, right? Set that contains nothing, and the set contains just 1. And if you think about it, we really can't add anything else to this, right? Those are the only ways that we can really have subsets of that. So for a set of size 1, we have 2. Let's look at one final example before we look at how to generalize it. So if we have the set 1, 2, you can think about it for yourself and feel free to pause the video, but you'll work out that there are actually 4 subsets of this. There's the empty set, as always. There's the set containing just 1, the set containing just 2, and the set I'll write down here around a space, set containing 1 and 2, so the set itself. And so there's a total of 4, right? Now let's think about how we found the subsets of this. This empty set contains neither. This one contains just the first but not the second. This contains just the second but not the first, and this contains both the first and the second. So really, we could correspond each of these, and I'll write them up here, to a set of 1s and 0s, and let me demonstrate how that's possible. 1, 2, and 1, 2. So let's think about why that's actually possible. So really, we can say this one contains not 0 and not 1. This one contains not 0 and sorry, it should be clear here. I'm going to write not 1 and not 2, right? This one contains yes 1, not 2. This one contains not 1, yes 2. This one, finally, contains yes 1 and yes 2. So really, what we have here is sort of a chart of all the different... We're boiling down each subset to not and yes. So this is if we're including 1 or not, and this is if we're including 2 or not. So what if we, instead of not, we wrote 0, and instead of yes, we wrote 1? Well then, this first subset could be represented by the number 0, 0 in binary, right? The second one could be 1, 0. Because it includes 1, it doesn't include 0. This means it includes 1, this means it doesn't include 0. or it doesn't include 2. This means doesn't include 1, this means doesn't include 2. The first one refers to 1, the second one refers to 2. This one we could write as 0, 1, and this one we could write as 1, 1. Well, how many different possibilities that gives us? It gives us 4, right? Because we have 2 different choices of 2. So our first choice, whether or not to include 1, we have 2 options, and because of some logic that is mentioned in the text solution about combinatorics, we multiply that by our second choice, whether or not to include 2. So we have, this is the 2 options of whether or not to include 1, this is the 2 options of whether or not to include 2. And that gives us 4 possibilities, right? So for any set, really, it's just the number of elements we can choose to include or not. Each element is going to give us a binary decision of whether to include it or not. And so the number of subsets, which are just representations of combinations of including and not including, is really just 2 times 2 times 2 times 2 times 2 n times, which is obviously equal to 2 to the n.